Hello and welcome to my presentation on shelter outcomes, a logistic regression model aimed at predicting the demographic of shelter dog most likely to be adopted. My project explored the theory that young spayed female dogs are the most likely demographic to be adopted out of shelters. To do this, my project used a logistic regression model to sort through and utilize a data set that I acquired from the Austin Animal Shelter. This was in hopes of predicting and visualizing the different demographics and their likelihood of getting adopted. From this particular data set, the following variables were considered: age upon outcome, type of animal, dog specifically, the type of outcome, adopted or not, the outcome subtype, spayed or neutered or not, and sex. The model aimed to predict shelter outcomes with the possible use of aiding and improving adoption rates in shelters in the future. My theory was that spayed females were the most likely to be adopted. Through research and anecdotal evidence, it is suggested that spayed female dogs have a higher chance of being adopted. This is because of behavioral advantages, health benefits, and population control. Spayed females and young dogs often have fewer behavioral issues. Spaying reduces the risk of certain cancers and infections. Spayed animals to avoid contributing to the overpopulation of unhoused pets. What is a logistic regression model? Well, a logistic regression model is a statistical method used to predict the possibility of a binary outcome based on one or more predictor variables. In this case in particular, the binary outcome is whether a dog is adopted or not, and the model is particularly useful because it provides the probability that a given outcome will occur, which helps in making informed decisions. Why use a logistic regression model? First of all, interpretability. A logistic regression provides coefficients that indicate the strength and direction of the relationship between each predictor variable and the outcome. Probability estimates. It generates probabilities, not just binary classifications. And it handles different types of data. It can handle both continuous and categorical data, which is essential for a diverse data set. Why this model works best for proving the theory. The logistic regression model is well suited for this, and this is because it can analyze multiple variables, generate probabilities, and handle nonlinearity, meaning the logistic function can model nonlinear relationships between the predictors and the outcome. This is the end result of my model. This GIF shows This GIF shows the rates at which dogs were adopted the older they got. It also includes whether they were neutered or spayed or otherwise intact. This model does show a sharp increase of adoptions in female spayed dogs after the age of 20. I predict that this is because there was only one entry. We now go on to our This section shows where we started by installing and loading necessary libraries and authenticating Kaggle as the dataset. Kaggle was a particular program that I needed to run this dataset, considering it did not come from Git. The dataset was then filtered to include only dogs and relevant variables like age, sex, and adoption status. I did have to exclude cats, and I did have to exclude non-applicables and otherwise unknown variables that were within the dataset. The age was converted into a numerical format for easier analysis, and the adoption status was encoded as a binary variable, 1 for adoption and 0 for not adopted. This is because they were not put in that original binary, and I believe they had been at 1 and 2. The dataset was then split into training and testing sets to evaluate the model's performance. A logistic regression model was then trained using training data focusing on age, sex, and outcome subtype. The model then predicts the probability of adoption for the taste data. Lastly, an animated visual the relationship between age, sex, spay-neuter status, and the probability of adoption. For this in particular, I had to individually code the average age of dogs that were adopted. My model originally looked like a bar graph, and it showed the average age of adoption, which had actually been around 2 years old. So. This once again is the model at the very end of my simulation. I'm pretty happy with how it turned out. And it seems that the highest demographic of adopted dogs are extremely young and spayed and neutered. In conclusion, my logistic regression model proved my theory that young spayed females are the most adopted demographic of dogs in shelters. As well, it tells us that neutered males were also far more likely to be adopted than neutered females and males. This means that the best way to increase adoption rates is to spay and neuter your dogs as soon as they enter the shelter, as is safe on a case-by-case basis. And as a finale, here's our question. In this data set, using this model, which variable had the heaviest weight? Age upon outcome, outcome subtype, spayed, neuter, not, or sex? Let me know in the comments.